Welcome to Analyze It. In this video, I will be talking about DBSCAN clustering and outliers detection in Power BI. More specifically, I will provide you an overview on DBSCAN clustering and outliers, how it works. I will show you how to implement DBSCAN in Power BI through Python. First, let's discuss what is DBSCAN. DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. This is an unsupervised machine learning algorithm. With this algorithm, you will be able to group data points with similar characteristics. Meaning, let's say you have a data set with different variables. So DBSCAN will allow you to cluster all your data points that have similar characteristics. DBSCAN is one of the many clustering algorithm, but it has the advantage that not only you will be able to identify clusters, but you will also be able to find outliers. As I said, for example, let's say you have a two-dimensional data set and you have data points with x1 and x2. You can plot your two-dimensional data set like you see in your screen. But when you apply DBSCAN algorithm, you will be able, for example, to find cluster. And in this case, you have two clusters. You have the point in red, a cluster, and the point in green, a second cluster. So you can see from your plot or from your data set, you can have two groups. You can group your data set in two groups. But in addition to that, you can also identify points that are outliers, such as those in black here are outliers. So this is what basically DBSCAN algorithm, a machine learning, an unsupervised machine learning algorithm will allow you to do. So how DBSCAN works to identify outliers? And for that, I think there's two things that you need to understand. The required input and the type of point. Let me start with the required input. The first input that you will need to provide to the algorithm is the epsilon. You have to choose it. And the epsilon is basically the maximum distance between 2 points for one to be considered as in the neighborhood of the other. This is the radius. This is the radius of the local neighborhood. Just think about the perimeters of that is surrounding a point. So this is basically the epsilon, and you have to choose it. And the second input you need to provide is the end clue. And the end clue is a number of points in a neighborhood for a point to be considered as a core point. Being said, using these two parameters or input that you need to provide DBSCAN, there are three types of points. Obviously, the first one is a core point, and those points have more than the end clue neighbor in their local neighborhood. So that means once you have defined the end clue, you will basically count the number of neighbor or the number of neighbors that you have in your perimeter or the epsilon that you have defined. And if this number is higher or equal to the end clue, so that point is considered as a core point. The second one is what called a reachable point. This point has less neighbor than the defined end clue. But because that point was reachable, or that point was part of the point that are neighbor from a previous core point, it is called reachable, and it will be part of the cluster. We'll see that graphically in a few seconds. And the last one, which is noise, or we call it outlier. This point has no core point in its epsilon neighbor, and it is also not reachable. So let's see this with a graph to explain you this concept. So let's say we have a two-dimensional data set, and we set our parameter epsilon equal 3, and we set the n clue equal to 5. So what I will do, and you can see here in this chart, the red one are what we call the core point, and the lighter one are the reachable, and the black one are the noise. So to explain you these 3 points, let me start with that one. So if I choose the epsilon of 3, and I will put this perimeter or of epsilon of 3 around at the middle of this point, which I'm doing right now, what you can see, you have 1, 2, 3, 4, plus the point itself, 5 points in this parameter around in the middle of this point. So, and we know that the n clue is 5, so therefore that point is a core point. Let's move on that one also, and we see the same process will happen. We set our epsilon of 3, and we put it in the middle. We put the circle or the perimeter in the middle of this point. And then we count the number of points in this circle. We say 1, 2, 3, 4, 5. So because we set our n clue equal to 5, so that point is also a core point. But what if we move in that point here? We do the same process. We set our epsilon equal to 3. We draw the circle, and we count the number of points within this circle, and we see that it is 1, 2, 3, which is less than the n clue that we have defined. So this point is not a core point, but because that point was counted or was reachable by that point, which is a core point, we will still consider this one as a point in our cluster. So let's move on that one and see what happened. We draw the epsilon circle, we count the number of points, and we see there's only one. So this point not only as it's not reachable by any of the core point, and the n clue is less than 5. So this is definitely, by definition, an outlier. So this is how DBSCAN works. So it will repeat this process for each point that are closed, and when DBSCAN finishes with that part, it will consider that section as a cluster, and it will go in the other part of the data set and repeat the same process to identify which point, for example, these are core, which these are reachable, and this one is an outlier. So this is how DBSCAN works. So as you can see, these two parameters, epsilon and n clue, are really key, and depending of the value that you provide, you may end up with different results. So you have to choose the epsilon and the n clue for running your DBSCAN. Okay, so we just saw how DBSCAN works, but let's see how to do that, and how the algorithm will do that for you for a data set with thousands of data points. So we'll do it in Power BI, and I will use Python algorithm in Power BI to run this process. Okay, let's move and let's jump on my Power BI, and we'll see how it is done. See you there. All right. Now I am in my Power BI desktop, and I've already my data set open in my Power BI. And as you can see, my data set is a 9-dimension data set. So that means we will implement a DBSCAN, trying to group um, each observation based on their similar characteristics, and the DBSCAN will use 8. I will choose 8 of these characteristics to cluster. So to do that, the first thing that we need to do is we need to go to the Power Query. So we'll go to Transform Data, and we select Transform Data, because we are still in the Power BI desktop, so we need to go to the Power Query. So you see that there is there will be a new window, and the window is a Power Query editor, and you can see that this is the Power Query editor, and the name of my dataset is customer, but I will explain you later a little bit of difference on what Python will be doing. But before moving forward, let me just tell you guys, the purpose of this video is not to teach you Python. You must have some basic understanding and basic background on typing Python code. So the purpose of this video is mostly showing you how you can use Python code in Power BI to run DBSCAN. And the second thing, and I think it's an important thing that I want to mention to you, is that to run Python code in Power BI, you must have already installed some Python in your local machine or your computer or your laptop. And you also need to have, all the library that you will be using in the Python script editor. For example, in that case, I will be using some 3 main libraries such as Panda, NumPy, and Cycliclearn. So all of these libraries and package must already been installed in your local machine before you can use them in Power BI. If you don't know how to do that, I would like to refer you to a previous video that I did, where I explain how to download and install all of these packages in your computer. All right, so let's move on. So to use Python script editor in Power BI, once we are in the Power Query editor, we go to Transform, and then you can see that there is R, and there is the Python script. So I will click on the Python script here, and you see that Windows is open, is open for us, and automatically what Power BI it's telling you is that all the data set that was customer, named customer, temporarily in the Python script editor, this data set is named data set. So anytime during your code or your script, you will be making reference to the data set that is a customer. You will have to type data set instead of customer. This is really important, and during the coding, I will show you where to put this. So the first thing that I will be doing is really importing my library. So I go in my script here, and I can type, I will import some library. So even though I install my basic library in my local machine, I need to call them again in the Python script. So basically, I will call Panda. So I will type import pandas as PD. Panda is a data frame library allowing you to make data manipulation, data transformation. So it's a good practice to always have Panda called in your Python script. And the second one is NumPy. NumPy is a mathematical library, so I will import it. Import NumPy as NP. And I will also, for doing machine learning, I will use Scikit-learn, and Scikit-learn is a really good library for doing machine learning in Python. So using Scikit-learn, I will also import the module that will allow me to run DBSCAN. So basically, I will type it. I have already did all of this code in a IDE, and let me explain you why I'm having. I mean, it's good for you to you can type, you can continue, you can type your Python code directly in the Python script editor. But the thing is that if you do a mistake, if you have to debug it, and it will be a little bit harder for you to find the mistake you have done. So the best practice for me is to have an IDE such as Spider or any IDE, to type your code, which will allow you to debug easily and your code, and then just copy and paste. So this is what I'm doing. I already have it in Spider, or you can use also Jupyter Notebook. So I'm copying and pasting in my code here. So that line here is that you can see I'm importing Scikit-learn, and from Scikit-learn I'm saying I want to have cluster, and from the cluster model I want to import DBSCAN algorithm. So this is what I'm doing here. And a second library or this, let's say, model that I want to import is Standardize, and you will understand why it is important, because you need to normalize it. So again, you can bring this module from Scikit-learn. Scikit-learn is a really powerful, interesting library for doing machine learning. So here again, you can see that I'm saying from Scikit-learn preprocessing, because I need to do some preprocessing. I want to import Standardize. So this is what I'm doing. So I'm done right now in importing the necessary library that I need to do, that I need to have in my script here. So the second step is to really doing some data processing. And here, why it is important to do data processing, guys? It's because, first of all, Scikit-learn doesn't work with non-numerical variable. And secondly, if you have missing data, you will get an error. So sometimes it's good. I mean, it's almost a must to do some data processing, data cleaning. And in this example here, I will do two types of data processing. And the first one is I'm going to convert all all the data, all the variable into a NumPy array. And you remember that we imported NumPy array. So Scikit-learn doesn't work with dataset as it is here. So you need to convert them in a NumPy array. So this is what you need to do. And for that, I'm going to call the NumPy array function that will transform your data set as an array. So I'm copying and pasting from my IDE, and you can see the code here. Basically, what I'm saying is that I call my data set. And again, you remember that I told you that our data set was initially called customer, but because I'm working with Python script, and at the beginning it says data set holds the input data for this script. So I need to make reference to data set, and I want to select age, edu, all of these variables, and then make them an array through the NumPy library, and I call all of these X. Okay, so that is my first data processing. And the second processing is basically normalize your data. And this is really, really important for DBSCAN and any clustering algorithm. Why? Because remember that, and if you look, for example, at your data set, you can see, for example, age and education, they are not at the same scale. So that means because you're going to measure the distance between the point, one point increase in a variable who don't have the same doesn't have the same scale with the other will have a higher impact. So you need to put all your variable on the same scale so that an increase in one point will have the same effect in all the variables. So this is really, really important to standardize your data set. So often to standardize your data set, you will use standard Sklearn. And what standard Sklearn is doing for you is that, let me put it as it is for you. The standard Sklearn will basically give this zero mean and unit variance for all your data. And we will use standard Sklearn to do that for you. So let me put a new row, and I will definitely call my, or let me type it for you. I'm copying from my ID, and I will explain you the code. All right, so as you can see, I will be standardizing my NumPy array that I call X. I will call the standard Sklearn model here, and I will feed it to my X, my array now, and I will transform them. So it will give you for each variable zero mean and unit variance. So those are the two data processing that I just realized I just did for my data set. But again, remember, if you have empty value, if you have missing value, you have to treat them. If you have non-numerical value, you can either remove them or you have to convert them into numerical variable. So there is a lot of transformation based on the initial situation for your data set that you need to do before implementing the DBSCAN. So now that we have called our basic library and we have done the data processing, we can run the DBSCAN clustering, and running this is just creating an instance of class, feeding that class to the normalized data and calling the labels. So this is what I'm going to show you how to do. Let me put the label for you, and you can understand it. So as I said, we will run the DBSCAN clustering, and we will feed an instance class. And for feeding the instance class, this is where we're going to call the algorithm. So the first thing that you need to I do here is that I call my instance of class DB, and then I call the DBSCAN model. You remember that at the beginning we have the DBSCAN that we import from cluster from Cycliclearn. So and then you remember in previously we were talking about epsilon. So here I need to I'm setting my epsilon as 3. So this is basically the parameter that I want to that I need to take into consideration for each of my point. And you remember when I said a num-clue, and the num-clue is a mean sample, so I set it as 2. So those are the two parameters we discussed previously on the presentation. So here I'm creating the instance, and the next thing that I need to do is that I need to fit the instance. So I will basically type db and calling, because this is db that I created my instance of DBSCAN, equal, and I say db dot fit. So I need to fit it to my x that I standardize. So x. All right. So now I fit it. So now I can call the label, right? Because if I run it here, it will run my DBSCAN and it will feed it to my x and the variables that I standardize to my array, right? So now I need to assign a class to, or a cluster to each of my data points. So to do that, so again, I will call dataset. Then I said I will name this, I will assign this new variable cluster, bracket, and I call the db, which is my, my DBSCAN dot and labels. Here we go. So now my Python script is done. So I will click OK, and I hope that I don't have any mistake. It will run for you, and it says you click continue, and it will ask you some question about the privacy. You just click ignore privacy, and you say save, and you see that it is running. It's looking at each of the point. It's already done, and you click table. So you're calling your table and assign the cluster to each of your data points. All right, so if you go at the end, you should get your cluster. And you see, for each row, it has assigned a cluster. For now, I have, let me see, the DBSCAN has created two clusters, 0 and 1. However, you remember that there are some outliers. So any data points where you have -1 is considered as an outlier. So let me see if where I can get, where are my, for example, if I unselect it and I say I want to see all my outliers. All right, so you can see I have 8 outliers in my data set. So all right, so I want to select all. All right, I want to remove it. Remove filter with a clear filter. Okay. All right. So let me see if I'm good. Yep. All right. So once I'm done, I just need to go to home and I need to apply, because I'm still at the Power Query editor. I need to say close and apply. All right, it's loading, waiting for the query. And when it's done, you will see it will add a new column as the assigned cluster. Here you go. All right, so for each of my data, you can see all of these are cluster 0. So I have 2 clusters, 0 and 1. And all right, so basically, you can see it has assigned cluster -1 are those considered as outliers. I have 0 and I have 1, so I have 2 clusters. So we can also do some visualization to see how many we have in each cluster and how many we have in as outliers. And let's do that. Okay. Now to do to visualize how many observation are classified as cluster 0 and 1, and how many are outliers. Let's do a pie chart, and to do the pie chart, we'll go obviously in report, and then we click on pie chart. We make it a little bit bigger, and so you can see it. Let me just apply changes. All right, and then this, make it bigger for you. Okay, so remember we did not use the customer ID in our clustering, so because it's a unique number for each individual. So what we're going to do, we're going to bring this unique individual ID, because we will count number of unique individual in each group of the customer. So we will bring this as a value, and then we will bring the cluster variable, which now has three value, -1, 1, and 0, and we bring it as a legend in the legend. And you can see basically given the epsilon value and the mean sample, the include sample that we have chosen, DBSCAN has classified almost 90%, 94% of our, almost 98% of our data point as in a specific cluster, which one is blue. And if we can see that 0.24% has been classified as cluster 1, and like almost 1% of our data set has been classified as outliers. Again, this is the result of, remember at the beginning I told you that the result depends on the level of epsilon and the mean sample. So if we had changed the epsilon, or increase it and increase both the epsilon and the include, you will get a different result. And you have to play with that, and there are techniques to define the best and the optimum mean sample or epsilon. Now, if you want to change the value of your epsilon and num-clue, or what the mean sample, you just need to go back in your Power Query and then click transform data, and then the Power Query will be open, and then you will go to transform, and you can go in the applied step, and you can see that you can click here, because you have all the steps that has been applied to your Power BI, and then you just click on Python script, and it will open. It will open up again the Python script editor, and you can do some changes. For example, if I want to increase the epsilon by, let's say by 5 now, epsilon 5, let's say 3, and then the number of points within the circle is 5, and I just run OK. It will rerun it for you again, and all the value will change. It will take some time, because it has to rerun it, and it's basically the same principle. Click table, and then say yes, continue, and then you see that it has created a new value. See, for example, now you have more. You have only 0 and 1 cluster and a couple of outliers. So you have to play with your epsilon and mean sample. I hope you have enjoyed this video, and you will explore more DBSCAN. In the chat box, I'm putting the data set, if you want, as well as the Python codes and some online reference for more information if you want to practice this. If you like this video, give me a thumbs up, and stay tuned for others video. Thank you.